Welcome to my channel. What if one field could grow two foods at the same time? Yes, rice-cum-fish culture is a smart farming system where fish swim beneath the rice plants, naturally fertilizing the crop while providing an extra source of income. Discover how this ancient technique is transforming modern agriculture into a more sustainable and profitable venture. Watch this video till end without skipping any part in order to updated information about silkworm and sericulture. This video is going to be very interesting and helpful not only for students but also for those who want to adopt integrated farming at their land. So, it is more important for you to subscribe this channel to get new videos on time. So, press the bell icon below this video. Also comment and like. And share this video with your fellows. Integrated fish farming. When fish culture is practiced along with other system crop or animal production, it referred to as integrated fish farming. It has been an ancient practice in China and the immigrant Chinese introduced into several Southeast Asian countries. Besides many developing countries Asia, some in Africa and South America, Madagascar, Central African Republic have introduced this system on pilot or larger scale. Some of the East European countries have also adopted other animals production fish culture. These small and marginal farmers have livestock in the form of cattle, pigs, a small flock of ducks of chick, agricultural land and surplus family labor. With these problem and resources, efforts are made to develop low-cost farming system based on the principle of productivity, utilization of farm wastes, available resource and manpower. Let's see the basic principle involved in integrated farming are the utilization of the synergetic effects of the interrelated activities and the conversation including the full utilization of farm wastes. Waste is only a misplaced resource which can become a valuable material for another product. The important feature may be summarized as under. The first one is waste or byproduct recycling. An output from one subsystem which otherwise may have been wasted becomes an input to another subsystem. Second one is improvement of space utilization, in which the subsystem essentially occupy part or all of the space required for an individual subsystem. The expected advantages of the integrated system are higher and stable farm productivity, better diet for farm family, more cash flow and income, better employment, less risk, employment and economic, environment friendly, optimum resource utilization. The integrated farming can be categorized into the following. Based on crop, it may be agriculture aquaculture, agriculture aquaculture birds, agriculture aquaculture birds livestock, agriculture aquaculture birds livestock apiculture. While on the basis of pond, it can be categorized as agriculture aquaculture, agriculture aquaculture birds, agriculture aquaculture birds livestock. Rice and fish crops are compatible and its culture is an age-old practice. Moreover, it matches to resource food habit and socio-economic conditions of the people involved. It is believed that rice field fish culture was introduced into Southeast Asia about 1500 years ago. It seems to have started in the 19th century in Indonesia, where it became an important peasant activity. This type of integrated farming was adopted by farmers in Japan, where people faced scarcity of food during the period of Second World War. Fishes can be reared in paddy fields. Fruiting, flowering plants and vegetable plants are cultivated on the dikes, as all fish culture is also becoming popular. Among the possible farming options in water-logged lowland field, the most acceptable choice is rice fish, since rice ecologies provide and is conducive for aquaculture. Let's see what is rice fish culture. The main crop of rice and fish farming techniques are modified to make them well suited for production of rice. Practiced in Far East and Southeastern countries. Following are the advantages of rice-cum-fish culture. No extra labor is required. Land is utilized economically. Weeding out of undesirable weeds is saved. Yield of rice is enhanced, make an essential item for food for rural people. Enhanced rice yield by 5 to 15%, which is due to the indirect organic fertilization through the fish excreta. Production of fish from paddy field, additional income and diversified harvests such as fish and rice from water and onion, bean and sweet potato through cultivation on buns. Fish control of unwanted filamentous algae which may otherwise compete for the nutrients. Tilapia and common carp control the unwanted aquatic weeds which may otherwise reduce rice yield up to 50%. Insect pests of rice like stem borers are controlled by fish feeding on them, mainly by murrels and catfishes. Fish feed on the aquatic intermediate hosts such as malaria, causing mosquito larvae, thereby controlling waterborne diseases of human beings. Waterlogged paddy fields are the ideal natural habitat of various types of fish. Fish also assist in making fertilizers more readily available to paddy. Rice fields may also serve as fish nurseries to grow fry into fingerlings. These pictures showed examples of rice-cum-fish culture. The fingerlings, if and when produced in large quantities, may either be sold or stocked in production ponds for obtaining better fish yield under composite fish culture. Considering these advantages, it is imperative to expand fish culture in the rice fields of our country. Ponds used for rice-cum-fish culture should have strong and little higher dikes, proper systems of channels or trenches and small pond or puddle. This picture shows the trenches for growing and shelter of fish. To start rice-cum-fish culture, site selections of prime importance. About 80 centimeters rainfall is optimum for this integrated system. Fields having an almost uniform contour and high water retention capacity are preferred. Important factors to be taken into consideration for selection of site are groundwater table and drainage system. Preparation of the paddy plot can vary according to the land contours and topography. It can be of perimeter type. The paddy growing area may be placed at the middle with moderate elevation and ground sloping on all sides into perimeter trenches to facilitate easy drainage. Or of central pond type. In this type, paddy growing area is on the fringe with slopes towards the middle as shown in the picture. It may be of lateral trench type, in which trenches are prepared on one or both lateral sides of the moderately sloping paddy field. Suppose the area of the integrated system is 100 by 100 meter like 1 hectare. The area to be utilized for paddy should be 82 by 82 meter I.e. 0.67 hectare as shown in the picture. The area to be utilized for fish culture should be 6mx 352 mi, 0.21 ha, 4 sides. The embankment area should measure 3 meter into 388 meter. And the area for fruit plants should be 1 meters by 388 meters I.e. 0.04 ha. This is an ideal ratio for preparation of an integrated system. Let's discuss the fish species which are suitable for integrated farming. The fish species which could be cultured in rice fields must be capable of tolerating harsh environmental conditions. They can thrive well in shallow water level below 15 cm depth. Fish can withstand fairly high temperature like up to 35 degrees centigrade. Fish can tolerate low dissolved oxygen, withstand highly turbid water, grow in shortest possible period. So fish species that can suitable for rice-cum culture include species have been widely cultured in rice fields such as Labiorohita, Catla catla, Oreochromis mosambicus, Anabas testudinus, Clarias batrachus, Clarias macrocephalus, Chenna striatus, Chenna punctatus, Chenna merulius, Heteropneustes fossilis, chanos, Lates calcariflin mughal species. Some fish species are shown in this picture. Culture of freshwater prawn Macrobrachium rosenbergi could be undertaken in the rice fields. The selection of species depends mainly on the depth of water, duration of water in the paddy field, nature of paddy varieties used. Two major systems of paddy-cum-fish culture may be undertaken in the freshwater areas, paddy-cum-carp culture and paddy-cum-air-breathing fish culture. While talking about paddy-cum-carp culture, major or minor carps are cultured in paddy fields. In the month of July, when rain water starts accumulating in the paddy plot and the depth of water in the waterway becomes sufficient, the fishes are stocked at the rate of 4 to 6,000 per hectare. Species ratio may be 25% surface feeders, preferably catla which stay on the surface of water for feeding and maneuvering, 30% column feeding like rohu which stay in the area between surface and bottom of pond for feeding and maneuvering, 45% bottom feeders like mrigal or common carp which stay on the pond bottom for most of the time. Air-breathing catfish are cultured in paddy fields in most rice-grown areas. Among air-breathing fishes, singhi and mug are most common. The waterlogged condition in paddy fields is very conducive for these fast-growing air-breathing catfish. Equal number of magur and singhi fingerlings are to be stocked at 1 fish per meter square. Chenna species are also good for this integrated system. There are two ways to practice rice fish culture: simultaneous culture and rotational culture. In simultaneous culture, rice and fish are cultivated together in rice plots, and this is known as simultaneous culture. Rice and fish are cultivated together in rice plots, and this is known as simultaneous culture. Rice fields of 0.1 hectare may be economical. Normally 4 rice plots of 250 meters square each may be formed in such an area. In each plot, a ditch of 0.75 meter width and 0.5 meter depth is dug. The dikes enclosing rice plots may be 0.3 meters high and 0.3 meters wide and strengthened by embedding straw. The ditches serve not only as a refuge when the fish are not foraging among rice plants, but also serve as capture channels in which the fish collect when water level goes down, as clear in this picture. There are some limitations of this culture system which are as follows. The simultaneous fish-rice culture may have few limitations, like use of agrochemicals is often not feasible. Maintaining high water level may not be always possible, considering the size and growth of fish. Fish like grass carp may feed on rice seedling. Fish like common carp and tilapia may uproot the rice seedlings. However, these constraints may be overcome through judicious management. Let's study the culture procedure of simultaneous culture system. The water depth of the rice plot may vary from 5 to 25 cm depending on the stocking density can be doubled if supplemental feed is given daily. After plantation of rice, fish fry are stocked at the rate of 5,000 per hectare. Fingerlings at the rate of 2,000 per hectare. The rice field are slowly drained off and the fish are harvested. The harvesting of fish may be done 1 week earlier than the rice. Individual growth of 60 gram per hectare, yield of 500 kg per hectare have been reported. Use of agrochemical is often not feasible. Maintaining high levels of water may not always be possible. Fish like grass carp may feed on rice seedlings. Fish like carp and tilapia may uproot the rice seedlings. Next type is rotational culture system. It means fish and rice are cultivated alternately. This practice is favored over the simultaneous culture practice as it permits the use of insecticides and herbicides for rice production. The rice field is converted into a temporary fish pond after the harvest. Water depth up to 60 centimeters can be maintained. Can be practiced 1 to 2 weeks after rice harvest. The stocking densities of fry or fingerlings for this practice could be 20,000 per hectare and 6,000 per hectare respectively. Fish yield could exceed the income from rice in the rotational culture. Manually weed removal from trenches. Removal of predatory and weed fishes netting or by devathing. Fertilizers can be applied. Cow dung at the rate of 5,000 kg per hectare. Ammonium sulfate at 70 kg per hectare and single superphosphate at 50 kg per hectare. Mohuya oil cake may be applied at 250 ppm to eradicate the predatory and weed fishes. Paddy-cum-carp culture, fishes are provided with supplementary food consisting of rice bran and groundnut oil cake in the ratio 1:1 ratio at 5% body weight of fishes in paddy-cum-carp culture. Paddy-cum-air breathing culture. In paddy-cum-air breathing culture, a mixture of fish meal and rice bran in the ratio 1:2 ratio is provided at the rate of 5% body weight of fishes. The fish yield varies from 700 to 1,000 kg per hectare in this integrated system. Survival rate of fish is less than 60%. Survival rate is maximum in renovated paddy plots when compared to fish culture in ordinary paddy plots. The dikes constructed for this system may be used for growing vegetables and other fruit-bearing plants like papaya and banana to generate high returns from this system. Thanks for watching. Like and share this video. Subscribe this channel to get more informative videos and to become part of a growing scientific community.